Okay, so today's experiment we're going to be making fireproof balloons. So the abstract today is heat is transferred to liquids very quickly. And gases, on the other hand, are much less conductive and therefore heat transfer occurs much slower than usual. Today we are going to take the advantage and the effect to make fireproof balloons. And so according to my hypothesis is that I believe that the balloon filled with water will resist the heat and the other balloon filled with only air will pop. And so the materials that we're using today is a lighter instead of a candlestick, one balloon filled with air, and the other balloon filled with the same amount of air and with a half a cup of water. And so today, the procedures for this experiment is to determine whether the balloon is filled with water or not, depending on what happens to the balloon, whether it is placed above the candle, and this is how we're observing the balloon, and that controls how much the balloon is inflated and how the amount of water in the balloon is taking place. And step 2 is to inflate one of the balloons and tie it up, in which I did early. Third is to blow up the same amount of air in this balloon and put a half a cup of water inside of it. And the fourth is lighting up the candle, which I'm not using. I'm using a lighter. And to be careful when using the matches or anything to avoid being hurt, burned, or anything. And fifth is to hold the balloon with air under the candle, under the lighter, and seeing what happens and record my data. And the second one is using the second balloon filled with air and half a cup of water and seeing and recording my data to see what happens. And so therefore, let's get started. So as you see, it popped because it's resisted the air. The amount of heat that's coming out of the lighter is causing it to inflate and blow up. And so, second one is that experiment didn't work. And so according to my results, my hypothesis was wrong and causing the balloon to blow with the amount of pressure that's going in. The balloon popped, and so according to my observations, the balloon explodes when on top of the lighter, but according to my data, it shows that both balloons don't resist depending on the amount of density and mass according to the balloons and filled with water. And so, determining how much thermal activity is involved with each of the balloons with only air and the other with both air and water, my hypothesis was wrong to be determined. And so I believe that the variation of colors kind of goes with it, and depending if you put the right amount of water and depending on the size of balloons and how much air is filled with. And so the balloon filled with air, most of the balloons are made with rubber, which has thermal conductivity, but the balloon filled with air is which has thermal conduction. Because according to the balloon with air, the balloon surface over the lighter will not be able to transfer much heat to the air inside the balloon, so the rubber surface becomes too hot, melting the balloon to explode. And so my hypothesis was wrong again. The colored balloon had water inside of it. The water also has thermal conductivity, in which the water was able to absorb the heat from the balloon surface, which was held over the lighter, but the experiment didn't work for me. So the potential of the balloon surface was kept low and it exploded, but the temperature was very high in which the balloon exploded and separated everywhere. So my experiment failed, but I hope you enjoy it. Thank you very much.